Every single day, this chilled powerhouse churns out over 100,000 tubs of ice cream, enough to satisfy an entire city's cravings. But behind that frosty lid is a process more complex than you might think. Massive mixers swirl molten cream, industrial blenders fold in flavor, and precision machines sculpt perfect scoops with military accuracy. And it all happens faster than you can finish a cone. But what kind of engineering makes a frozen dessert so irresistibly smooth? And how does this factory keep it from melting under the pressure? Let's find out. The moment raw milk arrives at an ice cream factory, the clock starts ticking. This isn't just any milk. It's carefully sourced from regional dairy farms, selected for their high standards in animal welfare, hygiene, and yield consistency. In the United States, where dairy reigns supreme, Wisconsin and California are among the largest contributors to the dairy pipeline that fuels the nation's frozen dessert industry. Globally, New Zealand, Germany, and the Netherlands also play major roles, with their dairy exports reaching hundreds of thousands of tons each year. These milk deliveries, typically transported in insulated tankers, arrive chilled to just above freezing, around 4 degrees Celsius, to preserve freshness and prevent bacterial growth. Upon arrival, every liter is tested rigorously. Samples are drawn to check butterfat content, protein levels, temperature, and bacterial count. Once cleared, the milk is offloaded into massive stainless steel silos, each capable of holding tens of thousands of liters. From here, it begins its transformation. The first major step is standardization, a process that ensures the fat and solid levels meet strict specifications. Unlike fluid milk, which can vary in composition, frozen dessert mix must be engineered with precision. Too much fat, and the final product becomes greasy and heavy. Too little, and it lacks richness and body. The optimal fat content typically falls around 10 to 16%, depending on the brand and style. Historically, this was a far cruder affair. In 18th century England, producing this sweet treat was a slow, manual operation that relied on ice harvested from lakes and packed with salt to lower its freezing point. Ingredients like cream, fruit, or honey were mixed by hand and turned laboriously in wooden barrels. Today, however, automated systems have revolutionized every stage. Once standardized, the base mix, made of milk, cream, sugars, and stabilizers, is blended in colossal tanks. High-speed agitators ensure uniform consistency, while emulsifiers are introduced to bind water and fat molecules, preventing separation during freezing. Before anything is frozen, however, the base must be pasteurized. This is one of the most critical stages in the entire production chain. Using large plate heat exchangers, the mix is heated rapidly to around 85 degrees Celsius for 15 seconds, then cooled just as quickly. This kills any harmful microbes while preserving the integrity of the ingredients. Pasteurization is not optional. It is a legal requirement in most developed nations and ensures consumer safety. Once pasteurized, the mix is sent to aging tanks, where it rests under refrigeration, usually for no less than 4 hours, but often up to 24. This aging process allows the fat to crystallize slightly and the proteins to fully hydrate, enhancing the final texture and melt resistance. Meanwhile, flavors are prepared, whether it's vanilla from Madagascar, cocoa from Ghana, or fruit purees sourced from regional growers. Each addition is weighed, mixed, and tested for balance and consistency. The challenge here lies in sourcing these ingredients sustainably. Vanilla, for example, is notoriously difficult to cultivate and subject to price volatility, with costs swinging between $200 and $500 per kilogram depending on weather conditions and harvest yields. From the aging tanks, the flavored mix enters continuous freezers, titanic machines that simultaneously whip and freeze the mixture to around -6 degrees Celsius. This stage is crucial as it introduces air into the product, creating what's known in the industry as overrun. Overrun refers to the percentage of air incorporated into the mixture, which can range from 20 to 100%. Higher overrun yields a lighter texture and greater volume, allowing producers to generate more product from the same amount of base, but it must be carefully controlled to maintain quality. In terms of machinery, this stage is where the factory truly comes alive. Modern freezers operate with rotating blades, pressurized refrigerant systems, and flow meters that monitor every parameter in real time. These units can process several hundred liters per hour, and some of the larger factories can produce upwards of 100,000 liters of finished product per day. That equates to millions of scoops each week. To put it in perspective, the global market generates over 28 billion liters annually, with the United States accounting for more than 4 billion alone. After freezing, the semi-solid product moves swiftly along to filling lines. Here, the operation branches into multiple automated lanes. Tubs, cones, or bar molds are fed onto conveyors, where they are precisely filled sealed, and labeled at lightning speed. Advanced robotic arms and vision sensors ensure accuracy down to the millimeter, rejecting anything that doesn't meet the exacting standards. For multi-layered varieties or mix-ins like cookie dough, chocolate chips, or swirls of sauce, injection nozzles synchronize with the mainstream to create complex textures in a fraction of a second. The speed at which this happens is staggering. On a modern production line, over 200 units can be filled every 60 seconds. That's 12,000 per hour, all chilled to preserve texture and form. Once filled, the containers enter spiral hardening tunnels, gigantic refrigerated coils that gradually lower the internal temperature to minus 20 degrees Celsius over the course of 1 to 3 hours. This deep freeze locks in structure and extends shelf life, allowing the product to remain stable for up to 2 years in commercial freezers. Labor plays a unique role in all of this. While the majority of large-scale operations are heavily automated, there's still a need for human oversight. Engineers monitor control panels, food scientists adjust recipes based on test batches, and quality assurance teams conduct hourly audits. In smaller factories, especially those focusing on artisan batches, there's a greater degree of manual involvement, hand-swirling sauces, packing cartons, or even folding mix-ins by hand. The blend of high-tech systems and skilled labor ensures both volume and versatility. Logistics are another crucial challenge. Moving hundreds of tons of temperature-sensitive product requires a sophisticated cold chain. From factory loading bays to central distribution hubs and then out to retailers, every link must maintain sub-zero conditions. Any lapse, even for a short period, can lead to ice crystal formation, a ruinous outcome that degrades both flavor and texture. In response, producers invest heavily in refrigerated lorries, insulated containers, and real-time temperature tracking software to protect every shipment. Costs vary depending on raw materials and energy consumption. Dairy prices, for example, fluctuate based on feed availability, weather patterns, and international trade policies. The global surge in demand for milk powders and butterfat has driven up costs significantly in recent years. On average, the cost of producing 1 liter of premium frozen dessert in a commercial facility can range from $1 to $3, with margins depending on packaging, branding, and distribution scale. Flavorings, especially natural extracts like real strawberry or pistachio, can be particularly expensive, often accounting for more than 30% of ingredient costs in certain recipes. The popularity of this dessert is anything but waning. The United States continues to be one of the top consumers per capita, with each person enjoying around 20 liters annually. Asia-Pacific markets are rapidly expanding, driven by rising incomes and shifting diets, while Europe maintains strong demand, especially in Italy, France, and the UK. This rising consumption has driven innovation, from low-sugar formulations to plant-based alternatives made with coconut, almond, or oat milk. Each new product line demands adjustments in machinery, ingredient sourcing, and testing protocols, proving that even a long-established industry must evolve to stay competitive. Tracing back to its historical roots, the journey of frozen dairy from an elite delicacy to a global staple is nothing short of remarkable. What was once served only in royal courts and high society parlors is now found in supermarkets and corner shops from Tokyo to Toronto. The invention of mechanical refrigeration in the 19th century was the turning point. No longer dependent on ice blocks and salt, manufacturers could scale up production, extend shelf life, and transport goods over vast distances. The Industrial Revolution didn't just change how we live, it reshaped how we eat. In today's facilities, cleanliness is paramount. Floors are sloped for drainage, air is filtered and pressurized to reduce contamination, and staff wear full protective gear. Clean-in-place systems flush pipes and tanks with caustic solutions and hot water, minimizing downtime and ensuring consistent sanitation. Microbial testing is carried out at multiple checkpoints, from raw material intake to final packaging. Every batch is logged, traceable, and stored for future reference in case of recall or audit. Despite all this technological progress, the core principle remains unchanged: to take humble ingredients, milk, sugar, and flavor, and transform them into a universally beloved comfort. Whether served in a cone on a summer day or scooped into a bowl at home, the finished product is a testament to modern engineering, global logistics, and the enduring joy of indulgence. And as the demand continues to climb, the factories behind the scenes will only get faster, colder, and smarter, ensuring that each spoonful remains as satisfying as the last. Thanks for sticking with us right to the end. If you've ever wondered what it really takes to get that perfectly smooth scoop from factory floor to freezer aisle, now you know it's a lot more than just cream and cold temperatures. From the global journey of raw milk to the precise choreography of industrial machinery, it's clear clear, this frozen favorite is a true feat of modern food engineering. If you enjoyed diving into the chilled world of production with us, there's plenty more where that came from. Why not check out one of our other deep dives into how your everyday favorites are made? You might be surprised at what goes on behind the scenes. Don't forget to give this video a like if you learned something new, and make sure to subscribe so you never miss a step inside the factory. We'd love to hear from you in the comments. What's your all-time favorite frozen dessert? Or is there another food-making process you're curious about? Let us know below, and it might just be the next one we explore. Thanks again for watching, and we'll see you in the next video.